This is Unit 11, Acids and Bases. Lesson 1, Arrhenius acids and bases. How are Arrhenius acids and bases identified? The objectives of this lesson: I can differentiate between an Arrhenius acid and base, I can identify the properties of acids and bases, and I can determine the products of a neutralization reaction. Do now. So as a brief reminder, what is an electrolyte? An electrolyte is defined as a substance that dissolves in water and forms a solution that conducts electricity due to the presence of ions. For example, sodium chloride is an electrolyte because when I put sodium chloride in water, it dissolves into its ions, sodium ion and chloride ion. Acids and bases are also electrolytes. An Arrhenius acid is defined as a substance that, when dissolved in water, increases the concentration of hydrogen ions, or hydronium ions. These words we'll use interchangeably, and so you should know both of them. So for example, when I put HCl in water, it breaks into its two ions, so I'm increasing the concentration of H+. Alternatively, if I put HCl in water, what that looks like in its aqueous is the H3O+, which is the hydronium ion. So for an example, which substance can be classified as an Arrhenius acid? To do this, you'll look at each of the compounds and break them into their component parts. Hydrogen bromide are the two ions, sodium chloride, lithium hydroxide, and potassium hydroxide. The one that increases H+ is an Arrhenius acid. Therefore, hydrogen bromide is our result. Properties of acids are: they have a sour taste, they can burn your skin, they react vigorously with metals to make hydrogen gas, and the pH is less than 7. So in your reference table, there are some names of common acids and formulas on table K. The top 4 are considered strong acids, and the last 2 are considered weak. So you can add those into your reference table to help you remember. Sometimes we talk about strong and weak acids, and we'll talk about strength later. Arrhenius bases are defined as a substance that, when dissolved in water, increases the concentration of hydroxide ions. So keep that in mind. So an example is sodium hydroxide. When it breaks into its two components, we increase our concentration of hydroxide. So the same question, which substance can be classified as an Arrhenius base? I'm looking for the one that will increase OH minus. So H+ and Br for hydrogen bromide, H+ and NO3 minus for nitric acid. Potassium hydroxide breaks into potassium and hydroxide. And sodium chloride. So the one that increases our hydroxide is our potassium hydroxide. Properties of bases are that they have a bitter taste, they can be corrosive, and they have a pH greater than 7. Some names of common bases and formulas are found in Table L and the reference table. They all contain OH except one exception is ammonium. Ammonia is considered a base as well. So we've looked at that before, but now you know it works slightly differently than hydroxide. The top 3 bases on Table L are considered strong, while the last one is considered weak. So what occurs when an acid is added to a base? The result is a neutralization, when all properties of the acid and base are lost. The products are a salt and water. So for example, when I add a base, sodium hydroxide, to an acid, I produce water and a salt. A salt is another name for a solid ionic compounds containing elements other than H+ and OH. Salts are electrolytes with high melting points and boiling points. So for example, label and name the acid, base, and salt. So we'll look at these compounds in the same way. If I break H2SO4 apart, that will be our acid because I'm increasing my H plus. This is our base, because if I break it apart, I'm increasing OH minus. Here's my water, and this lithium sulfate is a salt. Here I have a base, potassium hydroxide. I'm increasing my OH minus. Here I have an acid. I'm increasing my H plus. KNO3 will be my salt, because what I have here is water. All right, acids in table J. Table J in your reference table is the activity series, and we'll talk more about this next unit. But any metal above H2, so right here you see is H2 on the activity table in table J. Any metal above that will react with acid to produce hydrogen gas and a salt. Any metal below the table will not react with an acid. So there's only 3 below hydrogen that do not react with acids. When metals react with acids, this is an example of a single replacement reaction. So check your understanding. And now you can differentiate between an Arrhenius acid and base. You can identify properties of acids and bases, and you can determine the products of a neutralization reaction.